Hello everyone, I am Murugeshwari from the Department of Computer Science and Engineering at Shriram Engineering College. In this video, I am going to present my algorithms laboratory experiment. Now, let us understand the traveling salesman problem, that is commonly known as TSP. It is one of the most well-known optimization problem in computer science. In this problem, a salesman has to visit number of cities exactly once and finally return to the starting city. The main objective is to find the minimum traveling cost required to complete the entire tour. To solve this problem efficiently, we use the branch and bound technique. Branch and bound is an optimization method that divides the problem into smaller subproblems. Now we move to the program. In this first line, we import Java utility classes like scanner and priority queues. Next, create the main classes called TSP branch and bound. Next, create a constant called INF which represent infinity. And next, create a node class. Each node represent one state in the search. Int level. This variable store the level of the node. Int city. This variable store the current city. Int cost so far. This stores the cost traveled so far. Int bound, this stores the estimated minimum cost. In path, this array stores the path of the cities. Boolean visited, this array checks which cities are visited. Int RMAT, this matrix stores the reduced cost matrix. Then we move to the constructor. Node int n, this constructor create a node for n cities. Path is equal to new int of n. This create an array to store the path. Visited is equal to new boolean of n. This create an array to store visited cities. RMAT is equal to new int. This create the reduced cost matrix. This constructor create a new node by copying all values from another node. Then move to the comparison function. Public int compare to node O. This method compare two nodes. Next one is matrix copy. This function copies the cost matrix. And next, matrix reduction. This function reduce the matrix and calculate the minimum cost. Coming to the solving function, this function solves the traveling salesman problem. Priority queue node PQ is equal to new priority queue. This create a priority queue to store nodes. Node root is equal to new node in. This creates the root node. PQ.add root. This adds the root node to the queue. Coming to the main loop, while not PQ dot is empty, this loop return until the queue becomes empty. Node COR is equal to PQ dot poll. This removes the node with the smallest bound. If COR dot level equal to n minus 1, this checks if all cities are visited. This code checks all possible next cities from the current cities. Create a child node for each valid city. Update the path and travel cost and modify the reduced matrix to avoid revisiting cities. Then it calculates the new bound and adds the node to the priority queue only if it can produce a better tour. This code check if a valid tour is found. If not, it print no feasible tour found. Otherwise, it print the minimum tour cost and display the path in both 0-based and 1-based city numbering. It also reads the cost matrix from the user input. This main method reads the number of cities and the cost matrix from the user. Then it calls the function to solve the traveling salesman problem using the branch and bound algorithm and print the result. This output shows the result of the program. The user enters the number of cities and the cost matrix. Then the program solves the traveling salesman problem and print the minimum tour cost and the best path to visit all the cities and return to the starting cities. Finally, this program solves the traveling salesman problem using the branch and bound algorithm and find the minimum tour cost and the best path to visit all cities. Thank you so much for watching.